what is behind these robots? It's gonna be a world model. They also have to learn actions that are very high frequency. Robots today are very slow in doing something. So we want to have so-called objective-driven AI architecture that's trying to understand causality in this world, to understand from experience, from perception, to predict the consequence of things. So LLM sort of learn one model of the world secondhand. If you use today's LLM to give it a plan and tell it to do something, it can. It's like going over there, pick up a cup, and pick up the coffee. It's very, very slow. So we need world model to be able to actually understand the world in high frequency, real time. If you have a hallucinating agent, it's not safe. In the physical world, the consequence can be very dire. AMI stands for Advanced Machine Intelligence. AMI, incidentally, in French means friend.
Good morning, everyone. It's my great pleasure to welcome Professor Fung to this fireside conversation. One of the most eye-catching pieces of AI news in Europe this year has been the launch of AMI Labs, Advanced Machine Intelligence. Co-founded by Yann LeCun, one of the pioneers of deep learning and a Turing Award winner. AMI Labs has raised over $1 billion to develop what it called world models, the AI system that aim to go beyond today's large language models and build a deeper understanding of the real world, the physical world. This is a very important shift. Over the past few years, large language models have transformed how we think about AI, but many leading researchers now argue that the next generation of AI will need to move beyond predicting words and instead develop the ability to understand physical reality, reason about consequences, plan actions, and interact with the world more reliably. Professor Fung is at the center of this new wave. She's the co-founder and chief research and innovation officer at AMI Labs. Before that, she served as senior director of AI research at Meta, and she's also the chair professor at the Hong Kong University of Science and Technology. Her work spans conversational AI, multilingual NLP, human-machine interaction, responsible AI, and human-centered intelligence systems. So today's conversation is not only about the next technical frontier in AI, but also about a much bigger question. What kind of AI system should we build next? And how can we make them more reliable, more responsible, and more aligned with human needs? Professor Fang, thank you so much for joining us. Over the past 2 years, like most public attention in AI has focused on like large language models, like ChatGPT, Cloud, Gemini. Those are super powerful, like generating text, code, and increasing like images and videos. But there's like growing discussion around, especially among leading AI researchers, that the next frontier of AI technology may not just language models, but systems that can really build a deeper understanding of the world itself. So I know like AMI Labs describe its work as developing world models that learn abstract representation of real world sensor data and make predictions in like representation space. So Professor, for the audience, they may be like familiar with language models, but less familiar with world models. How would you explain like what a world model is and why developing world models may be important for the next generation of AI systems?
Yeah, indeed. Thank you. This is a very important question. I think everybody's asking this question now. In the last few years, generative AI, so LLM and diffusion models and such, they are indeed very powerful, very helpful. I think most of us use one version or multiple versions of generative AI every day. So they are indeed very powerful. And coming from my decades-long research background, in language and so on, I'm quite familiar with LLMs, the origin story, how it was evolved and developed, and how we actually start to see emerging capabilities, and then how we start to build agents on top of them. It's hard to believe. It seems like an entire era of large language models, but it's only been, I would say, even less than 3 years, right? Since ChatGPT came on, right? And but we are seeing, so in the last 3 years, we have been, we as in the entire field have been scaling the model and to use more data and the larger size models, use more post-training methods, and to sort of make the models to do better, perform better and have more capabilities and so on. And last year was the year 0 of agents. which are these autonomous, more autonomous systems that build on top of these generative foundational models, right? And, they help us code, they help us do all kinds of, workflow assistance and so on. They're indeed very powerful. And in 3 short years, this is a pretty amazing feat. But from research point of view, we have seen the scaling law sort of, it's plateauing, right? We are getting less and less return with even more data, so you're getting less kind of performance increase. And also we see that once we sort of optimize the model post-train for some better capabilities, we lose performance in other capabilities. So it's not really like going up anymore. And I think there's a consensus, right? So our co-founder Yann LeCun has been saying this in early 2021, already 22, that LLMs are not the way to learn the real world. And then I can cite other people, Ilya, from SSI, have been talking about, we need to have a world model. Demish from, GDM also talked about world model. Even my colleague, a good friend, Chris Manning, professor of Stanford University, he also talked about, learning world model. So what happens is that I think earlier we got very excited about LLMs because we feel like such models have learned about the world. They somehow learn a representation about the world through what I call secondhand learning, meaning from all the things that humans have written about the world. Right? We have written on internet describing different kinds of world and how things function, how we reason, what are the consequences of our actions and so on. So LLM sort of learn one model of the world secondhand. And, as we know, humans and even animals, we learn about the world. First of all, there's evolution. So it's sort of a pre-training of animals and humans. But in addition to that, we learn a lot in our first formative, really first year of existence through experience, so experiential learning, through sensory learning, right? Through a lot of multimodal learning, both supervised by humans, by our parents, by our surroundings and teachers and so on. Later on that we do the book learning, which is kind of like LLM. We learn, physics, mathematics, we learn logical reasoning, we learn philosophy from words, symbolic records of human knowledge. So LLM indeed are powerful, just like, it's more powerful any single person can learn, right? It's got great generalized knowledge and so on. So this is why LLMs are very powerful, and multimodal LLMs are also powerful because they have additional kind of image perception as well, right? So they can sort of ask questions through LLM today, what is the brand of this machine? What does it do? And then it takes a picture and do so this kind of thing. But again, it is sort of a secondhand learning. So for example, LLM can learn to solve physics problems about gravity, right? Very complex scientific theories and so on. And on the other hand, the generative model, when you ask it to generate something, it can violate the most basic of laws of physics because it doesn't relate like those sort of symbolic learning of the mathematical reasoning, physics reasoning. It cannot relate that to the experience of, what is the causality of things. If I hold up my cup of coffee, if I release my finger, what's going to happen? So there, it still learns from memorizing. I don't want to say memorizing, but from the images it has seen. So it doesn't really reason. It doesn't really relate these modalities because it's not learning firsthand, learning secondhand. Another problem with the language model, which is something that I've been working on since 2019, very early, which is the phenomenon of hallucination, right? Today, LLM hallucinates, image generation, video generation hallucinates. It looks very realistic. And once in a while, something weird is happening in the video. So today, I think all users, we are familiar with, okay, that's AI generated. If you go to social media today, people will just easily point out that's AI generated. So we have already become very good in identifying the flaws in AI generated image and the videos. And we're also capable of seeing like AI generated answers in text, right? It always gives you the most kind of, I don't want to say bureaucratic, like most predictable kind of content because it's learned the most standard of answers, right? And so when you want to be really creative, you still want to write things your way and so on. So And worse than that, I think it's not just about the quality, whether it looks good or whether it reads well, but that agents are supposed to help us perform tasks. And today we still cannot rely on these agents to be completely, reliable and faithful, because, simple things I look for a restaurant recommendation in Paris, and it will recommend, some very good recommendations, and sometimes it will recommend a restaurant that was closed more than a year ago. And then you say, wait, this place is closed. Oh, you are right. It's been closed. So there's a discrepancy between very sophisticated mathematical reasoning of LLM and very basic common, I wouldn't say common sense, but like very basic task, failure at very basic tasks. And this is because the architecture, the transformer architecture, enables it to learn secondhand from, a lot of things that's written, but it cannot quite learn things that are not explicitly written. We cannot write everything. So there's still experience in addition to text, right? So I think LLMs are here to stay. They're very, very good foundational models for us to use and to as a building block of a world model. What we need to do to understand so how are we gonna learn about the world, right? So that's what world modeling comes into play, which is a different architecture and different training objective. Don't forget, we train generative AI to generate token after token, pixel after pixel. So we want to have so-called objective driven AI architecture that's trained to understand causality in this world, to understand from experience, from perception, to predict the consequence of things. And to have also, don't forget, today's models don't have memory. So every time you put in all your context, whether to tell you what you could do and forgets. I mean, that's actually the simplest of things that LLMs are, So of course, people are hard at work to try to improve LLMs, to add additional auxiliary memory, all kinds of different kind of research methods. Fine, but ultimately the most efficient way really is look at, how we can model this world with this what we call, Army Labs. The full name is Advanced Machine Intelligence, but we're known as Army Life. Army, incidentally, in French means friend. So we want AI to be your friend. You're truly your friend with the same kind of belief system, and to understand your intention, your needs proactively, and understand the world, not just like you do, but better than you do. You should have super sensing, super understanding, and then it should have the super memory as well. Right. This is why we need a different architecture. I think today there's quite a consensus about like when you were modeling. A lot of people don't really know how to go about it. And Army Labs is proposing this new paradigm, I would say.
So before we go deep into the world models, I totally agree with you that there is a limitation of today's language model, but I guess for the audience, there might be a natural question that has LLMs has already reached its limit, or there is still a long way for the language models to evolve.
So it depends on what you mean by language model. So today's transformer architecture of this method of predicting next token to learn from language, it has to plateau because there's no more text data. Like we've exhausted all text data, right? You can continue to write more thesis or write more knowledge. It will increase marginally, right? So text data just pretty much exhausted that. So from this amount of text data, can you scale the model further to learn from the same thing? I mean, naturally, scaling just the model size is not gonna give you much anymore. You sort of squeeze everything out of it. Now, but I believe language model, higher level term language model. So it will become post-transformer architecture. It will become not just token prediction. I mean, and it will become world model. So it really depends on what you mean by language models. Today's, this transformer came out in 2018, 17, 18, right? So this generation of transformer-based token generating language model is plateauing, but it doesn't mean that we can use it to build different agents and other things. So there are still applications that we can use these models to build on top of. But there's a whole space of applications that need AI help that this kind of architecture cannot help because of the limitations I mentioned earlier.
You mentioned the agents, like many companies are now building agents, try to help us take actions, like use tools, browse the website or write codes, so on and so forth. We also talk about the limitations of the this high-level language model. So, Professor, in your view, like what's missing for the workflow of current AI agents, and how might like world model we are developing change the kind of agent landscape?
So today's agents, they are trained by sort of imitation learning or reinforcement learning in a very constrained environment and in a symbolic environment. What do I mean by that? Coding, right? The workflow of coding, you can collect, how people code in a very constrained coding environment. A lot of coding examples, and coding language is artificial, it's invented by humans. So it's, again, a very constrained, it's even more constrained than natural language. So, of course, such tasks, or even, any generative summarization, for example, machine translation, all these kind of symbolic textual language tasks, right? Language in the broader sense, which includes coding language, machine language, mathematical language, and so on. These problems are readily solvable, if not already solved. And agents built on top of these kind of learning can certainly perform all the tasks that require symbolic reasoning within a constrained environment. But our real world is much more open than that, much more complex than that. I want to make what's a good recipe to use in this? I want to make mapo tofu, right? I don't know if you cook. Like, I love cooking. Mapo tofu. How many recipes are there? Sure, it's easy to prompt and get a recipe. You know that 2 people can never make the same mapo tofu. This high frequency action of you want to put in the ingredients when there's fire and the temperature today. All this is, in fact, the space of possibilities of the right mapo tofu making is actually almost infinite. The fire flame, you cannot have this discrete space of how the fire is functioning, right? Imagine the human world. Most of what we do on a daily basis are like that. They're in the complex physical world with infinite possibilities, many ways of doing the right thing and many ways of doing it wrong, right? Whereas coding, in comparison, is much simpler, right? Code certain ways, it's gonna compile. Otherwise, it will just be buggy. It won't compile. Our life is not that easily, you don't have a compiler to tell you, how you should compile, how you should make the best, even the best Michelin chef making a mapo tofu. They can make amazing mapo tofu, 5-star. They can never tell you exactly you can replicate what they do. So this, you can write it down, you can describe the taste of mapo tofu and so on, but there's no way you can learn without watching people make it, watching people eat it, watching people step by step, describing how they feel. So the world is so complex, right? So other than, writing them down, we also record our actions, luckily, right? With all this video data, all these recordings, of course, image, right? How many of us like to go on YouTube and watch people how they cook? Or go on YouTube about how to assemble something I ordered from Amazon, despite the instructions, the written instructions. I have to watch YouTube about how other people are making it. Somehow YouTube help. YouTube videos help, right? Why? Because we need multimodal understanding. They help us to do things better. But today's online agent obviously cannot help us. And there's another future application. Maybe it's not so futuristic. It's coming very soon, which are these, robots, domestic robots helping us do chores. Today we have like 扫地机器人, right? We have this kind of floor clearing robots that works really well. But I want a robot also to, clean my desk, my dining room, clean my toilet, do my laundry, right? Fold it. Why not? We can have that. But then these robots need to understand all the infinite possibilities in the real world. We understand that intuitively, right? Then we're trained to do that. But then these robots also have to execute actions, right? The simple folding of laundry, we don't even think. We just look at how people fold, we learn to fold, right? But the robots have to do it in a way that's like the actuators have to do it just so, and so on. Now, so today there are robotists hard at work to make these robots physically more agile, being able to do very detailed actions. They can dance like humans, but can they fold laundry? What is behind these robots? It's gonna be world model, right? It has to be world. They have to learn. They also have to learn actions that are very high frequency. Robots today are very slow in doing something. If you use today's LLM to give it a plan and tell it to do something, it can. But it's like going over there, pick up a cup, and then pick up the coffee. It's very, very slow. That's impossible. So we need world model to be able to actually understand the world in high frequency, real time. It needs to, it needs to perform in real time, right? It needs to give instructions to robots to perform in real time. That has to be enabled by the AI behind, which is the world model. A lot of these actions in the real world, in factories, in building engines, jet engines, building an airplane, so on. They're crying out for like AI systems to improve efficiency, and not just efficiency, but safety. If you have a hallucinating agent, it's not safe. In the physical world, when it hallucinates, the consequence can be very dire. It can be even fatal, right? So the safety is even more important in in the physical world. So we cannot really build everything more and more everything on something that's fundamentally hallucinating.
The world is super complex, right? So you mentioned a few examples. Some are related to personal life, some are related to professional life. So when we think about the world model, where should we start? Like which kind of area, which kind of scenario we will like start to build this world model?
So industry applications, a lot of industry applications demand world model. A lot of tasks today, the industry are still using traditional AI, meaning pre-LLM, because LLM generative AI hallucinates so much, so they cannot use generative AI or agents to perform certain tasks, including monitoring or real-time safety monitoring and so on. So they are still relying on pre-LLM. I call it traditional, like pre-LLM, non-generative machine learning, or non-generative time series predictive models. But those models, pre-generative, they won't hallucinate, right? They're traditional classifiers and so on, but they're not very accurate. So we need to go beyond generative AI, beyond traditional AI, towards world modeling, to be more accurate, safer. All right. So there's a whole bunch of the whole world to be modeled, right? So industry applications for sure, safety critical applications, even consumer applications such as smart glasses. Today, smart glasses can tell you what's in front of you, can take pictures, can listen to music. It can do a lot of wonderful things, but it's not really actively helping you with anything, right? I would like to be able to, wear my glasses and, surgeon wearing the glasses and perform surgery. And the AI should be able in real time assist the surgeon on, what is the possible errors and don't do this and that to reduce, human errors to reduce mortality, right? This is what surgeons tell me they need, right? We have not solved that problem, but we're not going to solve that problem with generative AI.
So can I understand that the world model will be a bunch of models in different scenarios?
ARMY is building foundational world model. So we're building one model, one architecture for the world, right?
Yeah.
So we're not building a model that's really truly foundational based on, perhaps you have heard of JEPA architecture. So we're building that foundational model on top of which we can build sort of physical world agents. Imagine like today we have LLMs that are general, but then people can build on different applications, different agents on top of it. So we still need a foundational world model first. And then from there we can build industry specific applications and agents and so on.
And one thing you have already mentioned a bit is that like reliability and safety. So AI models, for example, like ChatGPT, when they make mistakes, it's probably not that consequential because it's you are just probably writing a paper or writing an essay, so on and so forth. But for the model which is helping us interact with the physical world, we'll have like bigger stake, right? When we design the world model, how to make sure it is like more reliable, it is safer.
So first of all, I want to go back to why LLMs are not safe, right? Why they hallucinate. They were trained to predict the next word. They were not trained to do any of the tasks you're talking about. They were trained to generate. So the other capabilities, we call them emerging capabilities. Think about the emerging capability. Emerging means somehow we discover them. We did not build them. We did not build these capabilities. We somehow discovered them. It came out. as a byproduct of generation. So we have no way of controlling it, completely controlling it. So we use a lot of engineering methods, right, to mitigate the risk, right? And I would say that it's not even true that LLM hallucination is not critical, because a lot of users today, consumers are using LLM, they ask for medical advice, right? So of course, all the LLM, providers have this disclaimer, right? You need to check. Also, often they will say, I'm not sure, this is the answer, maybe you need to check and so on. There's a lot of disclaimer and a lot of safety guardrail, right? But then people can jailbreak it. Right? Any safety guardrail, it's like a cat and mouse game. Anything time you put up a guardrail, people would, you can easily bypass it and so on. So it's not like it's not consequential. There are people using it for tasks that we tell you shouldn't use it, but they still use it, right? So having said that, yes, it's in the online world because the action is not taken in the physical world. Like even if it gives you the wrong medicine to take, you still have to go out and buy the medicine yourself and so on. You still need the doctor's prescription, because today I think LLM generated prescription is not valid in the pharmacy, right? You still need that. So it's like that. So if we have robots that provide action, that perform action in the world, of course, direct actions in the world. So which completely change the objective or the architecture where we are. It's like a state machine where its purpose, its training objective is to predict the consequence of every action in every instant. So when you do this, imagine what's going to happen now. Next step, if you do this, imagine what's going to happen now, right? So if you can imagine, you can say, okay, don't do that, right? And put it in this way. So because the model is trained to understand the world and to predict action or predict the world, if it can foresee the world, we can build safety objective into training. That's the hope, right? We're working on that. Our models, we're gonna teach it the consequence and the consequence of actions explicitly from the I don't want to say explicitly, but like from the architectures built such that it has to learn the consequence of actions. We're forcing this model to learn the consequence of things, learn the causality, learn to plan, learn to reason in the physical world. And then we test you. Can you, we have a lot of benchmarks, right? We test you. Can you now predict this? Can you now predict that? Right? So the entire objective of world modeling is different from the original LLM, generative objective. So that's how we can hopefully make it safer, right? And safety guardrails kind of post-training is kind of post hoc. As a scientist, I never felt comfortable with that.
I just have a burning question, like when you say teach the model to kind of predict actions. How do we get all the training data for this huge task? I feel like if we want to teach a model to really understand the whole physical world, then the training data, I couldn't imagine like how huge is that.
It is huge. Yeah. So the entire internet of text data is huge, but it's text. So it's very compressed form. That's why humans invented language. We invented language, symbolic language, right? Not just natural language, but like mathematical language and all that, because it's a form of compression of our knowledge. It's easier for us to communicate with each other that way. It's easier for us to record our knowledge that way and transmit our knowledge that way. So it's very compressed form. Human experience in the world, a lot of videos, but we're not throwing away language. The secondhand learning is still useful. It's like a human being who grew up with experiential learning, but like also then go to school. We go to school, we read books. So, but if we can read books in such a way that relates to our experience, right? Like, when you're very young, you read some books, you don't actually quite understand what it means. And then 10 years later, you again, or 30 years later, you read that, like Tolstoy novel, you go, oh, wow, now I get it, right? Because we have lived. So we don't throw away books. We don't throw away the textual knowledge, but we now need to focus on building like the first-hand learning experience of AI models.
Different models are also competing for resources, right? How do you guys like plan to build up the necessary steps to really make the model work?
Well, first of all, I think we're very fortunate to have been very well funded. But I think resource today, capital is one, but capital, there seems to be ample. The other resource that's kind of competitive and limited is compute. So actually one purpose of world modeling is to build more efficient, smaller models. So some of our previous work we have published before we started AMI show that the JetPower architecture is twice as efficient, half the size, and can do better job. This is one reason we do world modeling. So we don't need to generate, we need to understand, right? So compute that's resources, but we also have our infra team that's building optimal, infrastructure. Every frontier lab needs to have that strategy, right? How to have optimal infrastructure. The application space is so huge. Everybody's sort of trying to solve something. As a world modeling company, we're not directly competing against the LLM company. Maybe we're competing against traditional AI, which is not really much of a competition, right? It's just not very good. Another limited resource might be talent pool, like real talent. So there are a lot of people in this area today compared to when I started out. Maybe there were like a few hundred people, when I started out. But today, a lot of young people want to come into this area and so on. But the top talent that has the real experience and the really good intuition, really good experience and know-how to be able to do what we would like to do, it's a limit. But I feel that the way to compete is not through like a bidding war. It's not like I pay you more. That's totally the one way to go. The people will give up really high salary to join us because they believe in the mission. They believe that this is what's going to work, what's going to come next. So that's always been how startups succeed. Otherwise, there will never be any startups, right? So, and there will always be people who want to take the chance. I don't even want to say it's a risk. It's a very measured risk, world modeling, because we have results already. So but take a chance, from research to the market. It's a long way still, right? When I say long, I don't mean in number of years. It's not going to be a long, many years. Like it's going to be a short few years. But in today's world, few years is a very long time. So people who believe in this mission, this vision, and work together. And so there's a competition for talent, and I think us we're also pretty good in attracting talents. That a lot of people want to work with us. But of course, the market, I mean, we're not in the market yet. We are only 3 months old. But I feel like the market is not really a zero-sum game. It's really about growing this. Right now, the what's being solved is here, and there's a whole bunch of problems that are not solved.
When I see competition, for example, now let's say like OpenAI and Anthropic will go public, right? So they will generate a huge amount of capital from the market. Then they probably will dominate the computing power because they have like a huge amount of capital, and the computing power, like chips energy, are limited. The language model companies are generating huge amount of capital from the market, then they will probably dominate the computing power and dominate the energy. Then how we are going to compete against that scenario, that we probably have a better model, but we probably don't have enough computing power or enough energy.
Well, of course, we're building that, right? And also, if we don't believe LLM can scale infinitely. If you believe LLM will be more and more powerful simply by scaling, of course, whoever has the most compute will dominate. Yes, the rich will get richer, but the rich of usage, when you get more usage, that's when you will get richer because you will get more data feedback, then your model will get stronger. It's always been the case. You saw that OpenAI led for quite a long time with the ChatGPT because there were a lot of usage, right? But eventually Gemini caught up, right? Eventually Claude, Anthropic caught up. So within a few years, so nobody's like the de facto king or queen. We're far from saturating the application. We're not even touching the surface yet. I mean, there's so many applications. And so whoever can provide more usage will continue to get better. When you show the world that we have, capabilities, then I don't think we'll have problem raising more capital, right? And therefore having more resources. But it's not linear, right? It's not like, the more energy you have, then that's it. But even then, one day, if that's a bottleneck, we're not unprepared, right? We're already working on infrastructure research, right, to prepare for the future. Every frontier lab will think about the future.
Yeah, since we talk about future, I just have a question I always try to ask. Do you believe we will reach AGI soon? Like some people predict this year or next year we will achieve AGI.
AGI is so ill-defined. Depending on your definition, we have already achieved AGI. So original definition of AGI is an AI that can do more than one task. It can do multiple tasks without being trained to do so. LLM already does that. I'm not really in the business of defining AGI. Another way is to see that the AGI definition gets moving. The goalpost gets moved along the way, right? AMI stands for Advanced Machine Intelligence. So we do have a definition for that, and we work towards that. So machine intelligence that can reason and plan on its own with long-term memory, that can act on your behalf, that understand your intention and so on. That is advanced machine intelligence. Is that AGI? Depending on definition. So I think we're well on the path towards advanced machine intelligence or AGI.
So I know you are expert in like human-centered AI. One question I want to ask is when we talk about AI systems in the future, we talk about like how they can serve human, how they can meet the human needs and also in line with human values. How do you see that for world models, how they can kind of remain aligned with human values and human needs or social needs?
This is some research that's pretty new topic. I started talking about it last year. Not many people are working on it. So what we call mental world modeling, meaning that I want to build a model of the world according like a human's perspective, human facing or human centered perspective.
Yeah.
So it sees what I see, hears what I hear, but like super sensing what I might intuitively feel, I might not know, but I become I don't want to say a twin of me because it's a friend, right? It's a super friend, like a superhero, but my personalized superhero that's always there trying to help me, and it needs to understand from the human perspective as well as the physical context. And this mental world modeling we don't have today, which has this like understanding intuitively or like what I need, what I believe, what my background is, what I've done in the past, what my memory is. We don't have that. We don't have AI with like a personalized memory, long-term memory. We don't have AI today that can understand my personal value, because value is also very vague. I worked on human value alignment for LLMs before, and the way we do human value alignment for LLMs is basically through RLHF. It's like a reinforcement learning of with human feedback, right? We ask a lot of humans, say yeah, no, and then we give a lot of training data or even like moral principles and try to pump it, right? So, but today's models, its value really depends on how you prompt it and which language you're asking. And its value also depends a lot on the provider of RLHF.
Yeah.
What kind of value it aligned to. On the LLM side, there's an effort of open source LLM with open contribution from everybody around the world of their values so that it can align to different culture, different norms, and so on. So that's a very worthwhile effort to undertake, so that the models don't only align to the values of one geographical region or one political system and so on. So that's on the LLM side. And on the world modeling side, because right now we're trying to understand the world, understand human intention. That's how we're gonna model the values. It's not by sort of rule-based ethical principles and so on. I'm not a big fan of value alignment post hoc. It's like I want to teach the models to learn values itself. For example, if it understands the consequence of things, it will learn the value of what's safe automatically. That's what I mean by like objective-driven AI, where it would learn the consequences of things and avoid the risky behavior, right? And obviously, there are also things like much higher level laws and so on. And I think one model will be built and developed under such stewardship. Today, I feel like there's a discussion at the government level, so on, and even social media or civil society, a lot of discussions that are sort of kind of orthogonal to AI development. I am also involved with a lot of governance discussions, right? And I feel like it's almost a separate field unto itself. We're all talking, different stakeholders. We can agree, disagree on something, but it doesn't have direct impact on how AI is developed. Because what we discuss cannot be translated into algorithms directly.
Yeah.
So RLHF is one way of like sort of translating these values into prompts. The consequence is that it might or may not align with your values. We need to teach AI to learn the values by itself, right? Through understanding the consequence of action at the low level and high level, right? So do not harm yourself, do not harm humans. Of course, it's a value. We can teach it symbolically, but it's better that it predicts these actions and knowing the consequence is not desirable.
I know AMI Labs just like 3 months, as you said. You are going to achieve in the next 3 to 6 months. What you are going to achieve in the next few years? What is the real world application to world model? People talk about autonomous drive. People talk about like how it can be used in, like, for example, spatial analysis.
All of the above and more.
Okay. Yeah.
A lot of industry applications. There's robotic. I mentioned earlier constructions. I mentioned medical domain. Anything that's in the real world. But all human actions in the real world. And more, machine actions in the real world that can help us. And there are applications where we don't know today. That have not been invented, right? Until we have the model. Right, then people will come up with applications as well. But I mentioned these big, they're not applications, they're really industry. Different industry in the physical world, all the way to tourism, because tourism is about in this real world, right? Transportation is about in this real world, right? Construction is in the real, so on and so forth.
You are like from academia, and you also like work for Meta, like big tech giant before. So how do you feel like jumping into the almost like entrepreneurial world?
From academia to industry was because I always wanted to build models for real world application. Maybe not people know this, but I have done 3 startups. In this new era for LLM, I felt that to really build something that's grounded in real application, I had to move with the industry, both because of the possibility of making real products, to ground the research so that it will have real world impact, number 1. Number 2, also the resources behind. Big tech has a lot of resources, of course.
Yeah.
But so why did we start AMI? Because we felt that it is better for us to be independent and really focus on this, one paradigm, right? We were starting to work this kind of thing within the context of Meta. But today, being independent, we have the possibility of working with many other products and many other companies, and we can focus. We don't have to necessarily worry about existing Meta products. It's just different objective, right? It's like you're training a different model, same thing. Many people came out of big tech. So this path of going from big tech to entrepreneurship, I think today is actually quite common. Many of my ex-Meta colleagues are in various startups, not just with us, but they've started other startups as well, because there's so many possibilities, so many applications, from upstream architecture to downstream application. There are just so many possibilities. And entrepreneurship is about trying to go for the next disruption. Entrepreneurship is about taking the jump, taking the risk. Entrepreneurship is about believing in your mission, and with single-minded, commitment to that mission. Meta was the first time I worked for Meta. It was called Facebook. Facebook was a startup, right? This is just natural. It's just a natural ecosystem. There will always be startups. I'm sure one day when we become big, and there will be people graduating from us to start other companies as well. Personally, I want to make real world impact. And personally, I want to do things that mainstream is not doing. I've always done that. Like not following mainstream and looking in the future.
Yeah, that's great. So our audience include lots of entrepreneurs, also like students, researchers. I know like a lot of them are embracing AI and also or get prepared to embrace AI. So what's your suggestions to them, like especially when we are now in this new era, like LLM is super powerful? What kind of things you think they should pay attention to, or which kind of skills they should start to build up in order to be more competitive in this new era of AI?
So one almost indispensable is that to become AI native. You need to know AI, all the AI tools, agents that come out, just use them. One is that you need to be AI native in order to be competitive, but also when you are AI native, you know the limitation of AI. I talk about limitation of LLM because I worked on it. I really worked on trying to mitigate hallucination and so on, right? A lot of people in our company came from generative AI background, whether it's diffusion, or LLM, right? So become very AI native, and understand why it works, why it doesn't work. Then you will see like where the next opportunity is. And if you are not AI research, for example, you are the application, it takes a whole world to do world modeling, we need people who are working upstream research, we need people working on engineering, application, integration, agentic, people who know how to invest, people who provide data. So there are a lot of opportunities in the entire value chain.
Professor, do you have more you want to share, like in terms of AMI Lab or in terms of yourself, or in terms of world model?
I think, as I said, it takes the entire world, it takes not just a village to work on world modeling. I think we should feel, each one of us should feel this mission of building a better world through AI for our future generation.
Yeah.
I think we are mission driven, whichever role you take as a researcher or you're a student or if you're an investor, or you're an application builder or an industry user, a decision maker. Ask yourself, what is your mission, right? Our mission should be for a better future, a better tomorrow, and a better planet, and world peace. It's not hyperbole because we're really